So we're going to do the surface area now. So if you like, this is another example, the surface area of a sphere. This is a good example, and one, as I say, that has a really nice answer, so it's worth doing. All right, so first of all, I'm not going to set it up quite the way I did in example 2. Instead, I'm going to take the general sphere because I'd like to watch the dependence on the radius. So this is going to be the radius. It's going to be radius A. And now, if I carry out the same calculations as before, if you think about it for a second, you're going to get this result. And then the rest of the arithmetic, which is sitting up there in the case A equals 1, will give us that ds is equal to what? Well, maybe I'll just carry it out because that's always nice. So we have 1 plus x squared over a squared minus x squared, right? That's 1 plus y prime squared. And now I put this over a common denominator. I get a squared minus x squared, and I have in the numerator a squared minus x squared plus x squared. So the same cancellation occurs, but now we get an a squared in the numerator. All right? So now I can set up the ds, and so here's what happens. The area of a section of the sphere, so let's see, we're going to start at some starting place x1 and end at some place x2. So what does that look like? Here's the sphere, and we're starting at a place x1, and we're ending at a place x2, and we're taking more or less this slice here, if you like, right, this section of the sphere. So the area is going to equal this, and what is it going to be? Well, so I have here 2 pi times y. I'll write it out, just leave it as y for now. And then I have ds. All right, so that's always what the formula is when you're revolving around the x-axis. And then I'll plug in for those things. So 2 pi, the formula for y is square root a squared minus x squared. And the formula for ds, well, it's the square root of this times dx. So it's the square root of a squared over a squared minus x squared dx. All right, so this part is ds, and this part is y. And now, I claim we have a nice cancellation that takes place. Square root of a squared is a. And then there's another good cancellation, as you can see. So what we get here is the integral from x1 to x2 of 2 pi a dx, which is about the easiest integral you can imagine. It's just the integral of a constant, so it's 2 pi a times x2 minus x1.